So again, welcome everybody to the CIBSE Energy Performance Group Virtual Power Hour. If I can just take you through, the CIBSE Energy Performance Group has a particular mission. And hopefully, yes, that mission is now hopefully being displayed on your screens. There are 4 items that we try to do. I'm not going to bother reading it to you. I hope you can all read it yourselves. You can be a member of the CIBSE Energy Performance Group without being a member of CIBSE. You just need to sign up on the website, which is you'll find if you type in CIBSE EPG or CIBSE Energy Performance Group. Obviously, we'd like you to be members of CIBSE, but that's not a prerequisite. And the idea is really to discuss and address issues associated with the energy performance and generally the performance of buildings. So the Power Hour, this is an event, a format that we've run many times in physically, and as I was saying earlier, this is the second time we're doing it virtually. And it's really pretty simple, actually. We ask a number of speakers, 4 or 5 speakers, to talk about the subject. We try to get a wide range of speakers from different backgrounds to spice it up a little bit. And the idea is that the Power Hour will go on for just 1 hour. Because of the way it's become virtual, we're doing it slightly differently, so it becomes more of a conversation between the moderator, which is me, and the various speakers as we go through those presentations. To introduce myself again, my name is Roger Macklin. I work for Hawley, but I'm also chairman of the CIBSE Energy Performance Group, and I will be your host for the evening. As I said a little earlier, at the end of the Power Hour, we're going to host a number of breakout spaces. Possibly not like this, possibly looks rather like the inside of wherever you're sitting at the moment. But the idea is to try to engage in conversations which come out of this event. So at the end of the Power Hour, or just after the Power Hour, we will post into the chat some links to just regular Microsoft Teams meetings that can then follow on and carry on the conversation, but in a much more of an engaged way between the participants and others. So hopefully you have now all seen the web link, which is in the chat screen, and what we'd like you to do is to click on that web link, perhaps now or a little bit later on, as long as it clearly doesn't take you too far away from this presentation, this event, and we'd like you to vote on the next subject for the CIBSE Energy Performance Power Hour. There are a total of 7 subjects that we are proposing that we could talk about next time around. And what we will do is gather all the votes using this Slido app to identify what that will be. So it would be great if you could all log on to that, and maybe towards the end of the event, we will have a look and see what the results were, and hopefully maybe tell you what the next subject will be. So if we can sort of start this process. Oh, and by the way, the Power Hour, which is this hour-long event, doesn't include this initial chat by me, so I can be pretty lazy about this, whereas the speakers have a very short period of time for which they have to get on and make their points. So the subject this evening is COVID-19, perhaps unsurprisingly, and really how it's affected energy use now. And what its lasting legacy is likely to be. We've got 5 speakers lined up for you this evening. They're really good speakers. Apologies for formatting, that seemed to have gone a bit awry. But I will introduce those speakers as we go along. So that's probably pretty much the end of my blathering. I will stop sharing my screen, and then I'd see if you could possibly share your screen, and we can get on with that. So if I could introduce our first speaker, there you go. So our first speaker is Dr. Atsi Boerstede. I suspect I've got that pronunciation wrong, so I do apologise. He is with REHVA, which is the Federation of European Heating, Ventilation and Air Conditioning Associations. He's also the managing director of a company called BBA Binen Milieu, which is a consultancy company that specialises in indoor air quality, thermal comfort and light, and he's based in The Hague. What's really interesting and very exciting for us actually is that Atsi is very kindly given up his time this evening from holiday. I believe he's camping somewhere. So as a consequence, the sound quality we hope is going to be really good, but it might be a little bit of a struggle, and I may have to restrain myself from asking too many questions. Adsi is also a visiting lecturer at more universities than I can put on one hand, and he's also the president of the REHVA World Conference Klima 2022, which is going to be held in Rotterdam. And he's going to start really just by giving us a sense of some of the explanations about the COVID-19 guidelines. Adsi, over to you.
Thank you very much, Roger, for the introduction. Like Roger said already, I'm camping somewhere in the middle of nowhere in Germany, so it's all a little bit improvised. My colleague Stijn is helping us. He's presenting actually the slides, and I'm in connection by phone with Stijn, but we tried it out. It should all work just fine. Yeah, about my presentation. I've been personally very busy the last 3-4 months with a lot of REHVA colleagues actually working on the COVID-19, and I would like to share some ideas with you about COVID-19, also in the context of the energy transition. Next slide, please, Stijn. If you talk, because now certainly everybody's talking about health indoors, fighting infectious diseases, maybe with ventilation, and it sounds like this is something new to talk about this and not about energy efficiency, but actually it is not, I think. If you go back about 150 years in time, we already had a lot of people all over Europe talking about this, hygienist, and a famous person, of course, is Florence Nightingale. Nurses and doctors always refer to her in times like this as the woman that introduced good hand washing and hand hygiene in times of disease to fight cholera and other infectious diseases. If you look in what she really wrote, for example, in this booklet, Notes on Nursing, and there's another interesting one, Notes on Hospitals, she talks about cleanliness and about hygiene, but she also talks about the need for good ventilation, pure air, pure water, efficient drainage, sunlight. So she was already pointing the direction also towards engineering solutions when you talk about infectious diseases. So I think we should remember Florence Nightingale when you talk about issues like COVID-19. Next slide, please. Of course, if you talk about infectious diseases and maybe, for example, using ventilation to get rid of viruses in the air or aerosols with viruses in them in the air, I'll get back to that later. A lot of people then, of course, start to question, but doesn't this lead to extra energy use? And do we have to choose between health and energy use? I'm not too sure about it. I personally believe that if you have a good design and a smart operation of buildings, you can do both. And in that context, I would like to show this graph. It's a little old already, but it was a big European study. One dot is one building. These are all office buildings. And what the study showed is that a certain amount of buildings, these are the buildings within the red circle, that some of these buildings, they did pretty good in terms of energy use per square meter, but also in terms of having very little building symptoms, like SBS symptoms. And other buildings had actually both very high energy use and pretty bad score in terms of symptoms and health experiences from people. So I just wanted to show this picture to communicate to you that I really believe if you do good work, you can do both. Create good energy efficiency and also good health performance. Next slide, please. If you talk about the transmission routes, this complicated figure is something that we've used already from end of March with REHVA, just to communicate what kind of transmission routes people are talking about. if you talk about COVID-19. And I'm not going to go through them all in detail, but the latest research showed that big droplets, the ones that you spread when you sneeze, for example, when you cough, and many of them they go to the ground within 1.5 meters, something like that. But that also micro droplets, like the smaller ones, that float in the air and actually can stay floating in the air for, I don't know, a couple of minutes up to sometimes maybe even an hour, that those are the two important ones. So the big droplets and also the ones, see the circle in red, the aerosol or the micro droplets. And especially when you talk or when you sing or whatever, the majority of what leaves your mouth is actually are these micro droplets smaller than 5 to 10 microns. So this is something very important to look at. And next, please, you see already that, for example, in Nature, they started publishing papers where they say that this aerosol route is a very important one. And also, next, please, the European Centre of Disease Control. This is like the Public Health Institute advisory organ of Europe. Also has started publishing these kind of documents about heating, ventilation, and air conditioning in the context of COVID-19. You see more and more organizations. I also know that UK Health has published something about the need for good ventilation, for example, and Germany of the Koch Institute. So there are more and more institutes in Europe that now start to communicate that it's important to fight these aerosols too, and to use, for example, ventilation as one of the measures.
Actually, can I just ask a question there? So do you think that this is everything that we are going to know about the transmission routes? Because presumably this graphic that you've generated will have evolved over the last 3 months or so.
Yeah, it's to be honest, when we first published the graph, we believed that there was more happening than there actually is happening on the toilet side, so down below. Even though there were few incidences in Asia where there are good indications that if you have like toilets that you flush and people did a big message. How do you say that? I never know it's number 2 or number 1, but the big one. If you flush it without the lid closed, then actually you get aerosols filled with phases particles that also can lead to infections. But I think from the studies we've seen since March, at least we have concluded that the droplets, the big droplets and the small droplets are much more important than the other part of the graph. And the latest, I think it depends very much on the context. So if you are, for example, in a nursing home or in a hospital where a lot of people are coughing and sneezing and whatever, then probably the big droplets are more important. But if you talk about healthy people that go to a discotheque or a bar and they sing and shout and they are infected but they don't sneeze and cough yet, then probably the aerosols, especially when they are in badly ventilated situations. So it depends very much on the context, which of the routes are the important ones. So I really believe that the things we do, the mitigating measures we do in buildings, have to depend on the context. There's not no clear answer to this. How about if Stijn, go to the slide number 5, the REHVA COVID guidance slide? Yes. That's okay. So I'm not going to go in all the details. I see that I forgot to mention the link here. If you just search for REHVA COVID-19 guidance, you get the document on our website. On the right, you see the present guides. We are very close to writing the next version, and then we will have a few changes, not radical changes, but we'll have actually 15 instead of 14 measures. But in the picture to the left, we try to describe what the main things are. The one is ventilation. Just make sure that on a room level there's enough fresh air coming in, and of course energy people maybe don't like these, so you have to do it in a clever way, also in winter, so you don't overuse energy. But anyhow, fresh air supply on a room level, especially in smaller rooms, it's ultra important. Recirculation is something to look at. If you overdo that, and you bring in to the building back the contaminated air, it's not a good idea in times of COVID-19. Filtration, sometimes you can use filtration or air cleaning in a very efficient way. For example, at room level with recirculating filters. It's a little bit tricky business, but there are certain filter technologies that work pretty well, probably. And then cross-contamination. This is like contamination between rooms. It has to do with pressure differences between rooms. Think, for example, of nursing homes. You don't want, if an infected person is in a room, you don't want the viruses to go to the corridors or to go to other rooms. So you have to think about pressure differences. And the last one is relatively new and will be also addressed in the new REHVA guidance is verification, because if you have certain buildings running, it could be a classroom or a restaurant or just a meeting room, you want to be sure that it's safe. So it's I think, a good idea to introduce indoor air quality continuous measurement, like sensor networks. And that keep an eye on momentary air quality and can warn people actually when the CO2 levels go up. So that's something new we've added in a new guidance. Okay, before I close, I just wanted to show the next slide. Just to point out to you that in situations where you think, or where we think, that the aerosol route is very important, so the airborne route, there is good news, because there's some good theory about how to calculate what infection risks are in relation to the airborne route. This is the so-called Wells-Riley theory. Some of you might have heard of it. I'm not going to go in all the details of the formula, but it basically says that infection risk is related to a few things. One is the amount of infected persons in the room. The other one is assumptions about virus load, and we know that actually from empirical data. And we know it's more when people do sports, or when they shout, or when they sing, than when they sit quietly. We do have already some numbers about this. It depends on pulmonary ventilation. So if the uninfected persons are breathing a lot, so for example, when they do sports, they inhale per minute or per hour more viruses that might be in the air than when they sit still. So the P is an important one. And exposure times. If you're in an elevator with somebody who is infected and who's spreading out viruses, it's much less dangerous than when you are with the same person in the meeting room, because you are much longer in the meeting room than in the elevator. So you also have to think about exposure time now. And this all is affected by hourly room ventilation, which in turn depends on air exchange rate and also room volume. So in higher, bigger volumes, there's a much smaller chance, think of a big church, than in a small space. So. Okay, to the right, so you get a little bit of feeling, and some of you might have seen these kind of calculations already. This is just an example of an office building. If you compare infection risk, like again, calculated with the Wells-Riley formula, for example, a 2-person office room, which is a relatively small space, compared to a 10-person meeting room, compared to like a 50-person open plan office, you see already that the bigger space becomes the smaller the infection risk. And personally, I'm not a big fan of open plan offices because of sound and acoustics and disturbances. But if you look at, I don't know, the infection risk, like it's indicated here, it might be time to re-evaluate maybe the ventilation rates for smaller offices. So for what we do now, standard is pretty okay, maybe for big open plan offices, but I'm not too sure about present ventilation rates, even though I've been involved in some of the European standards. I'm not sure that they are enough to keep people free from infection risks. So. Okay, my last slide is about the energy impact. I'm not going to go in all kinds of details because the other presenters will talk about this too, but I see at least these 4 things that are pretty tricky if you look at COVID-19 measures that you might want to take, especially before next winter. And on the one hand, and energy use on the other hand, there's good evidence that looking at the aerosol route, especially in spaces where people spend more time, it's important to boost fresh air supply. And of course, when you do that when it's really cold or really hot outside, this really has an energy penalty. So that's quite tricky. Use of recirculation. We do know that it could be unwise in some situations to overuse recirculation. I'm talking about especially central recirculation in air handling units. Of course, that has an energy effect. use of leaky heat recovery systems like anti-breathing rules. The modern ones, they normally are designed pretty okay, so there's hardly any leakage through the system, but older ones might also re-enter some of the aerosols, especially viruses from the return side, but this is not such a big issue as, for example, number one here, fresh air supply boost. And a lot of people now are talking about the application of additional, more advanced filtration systems inside the ventilation ducts, like HEPA filters, and they come with big and high pressure drops. And I'm not sure that this is actually possible and also wise from an energy point of view. In some situations, yes, maybe in nursing rooms, but definitely not everywhere the solution. So thank you. And if there are any questions, please let me know.
So actually, let me just answer a couple of, there are a couple of fantastic questions coming up in the Q&A. So thank you to all the participants for that. There were just two quick questions I'd like to pick up. One I think is real simple. One's a question which asks, are CIBSE and REHVA aligning their guidance on ventilation operational issues?
Yes and no. I mean, we did not write it simultaneously. So the first version of REHVA was before the CIBSE guidance, and of course now we are rewriting the REHVA guidance. We can look back at the CIBSE guidance. So there are definitely contacts. We look at each other. We also look at what ASHRAE is writing. We have contact with Hong Kong, for example, with Australia. Everybody's looking at everybody. And in an ideal world, it would be fantastic if everything was 100% aligned. I think you can easily say that maybe 90% is aligned now. So it doesn't have very big differences, but it's not 100% the same. Right?
Okay. And then just real quick, because we are time is always running short. Just a quick thought from you on the importance of humidity.
Mm-hmm. Yeah, I'm not too convinced that it has, well, a lot of effect. If maybe any effect. A lot of people are talking about this, like, okay, let's fine-tune temperature, let's fine-tune humidity. And I think what's happening on the ventilation side is an order of magnitude bigger and more important than what happens on the humidity side. Yes, there are extremes. People are talking about meat industry, where it's like 10 degrees Celsius or lower. It's pretty cold. It's super humid too, so they keep these meat factories very humid because then that adds to the weight to the meat. So there are certain circumstances where humidity, because it's extremely cold combined with extreme high humidity, might play a role. But if in a standard office or standard school you want to do things to make the building safer, I think you can do much more with your pounds or euros if you put that in. I don't know, increasing ventilation rate, putting in better filters, then in alternating humidity levels, maybe adding a humidification system, or yeah, not too much is happening in that corner, I think. Having said this, there's a lot of arguments about this. Some people don't agree with me about this one. So, but that's at least within REHVA how we've approach this, and even in the REHVA guidance it says on black, it's not really, it doesn't really help much to alter humidity levels in buildings. I'm not sure exactly how we wrote it, but something like it.
Well, thank you. Ati, thank you very much indeed. That was a really interesting presentation. I suspect that the humidity question will go on, and maybe that's one of our topics of conversation. But thank you very much indeed for joining us from your campsite. I hope you have a good holiday. So our next. I
won't be able to join the breakout room sessions later on. Sorry about that, but.
Okay, well, I think your contact details were on the slide, so perhaps people can contact you directly. So thank you very much indeed.
Around August 10th. So if people have questions, I'll look at those after that, if that's okay.
Okay, thank you very much indeed. So our next speaker is Quentin Babcock, and I'm interested to note that Quentin has kindly decided not to sing and shout in a nightclub tonight, but to join us instead. Quentin started his building services career in 1999, working for some organisation that I don't really know or understand called ACOM. Apparently, he spent 5 years in their applied research department working on updates to building regulations. And he's now been with Transport for London since 2006 and works in the head office infrastructure and sustainability team. Which is good. The first time I met Quentin, he was asking someone if they could print off the manual for the building, which I was aghast at because he was the sustainability officer. Anyway, I won't hold that against him. Quentin, thank you very much for joining us. Off you go.
Right, yeah, they still managed to lose it. Never mind. No, it's tucked away in the cupboard, never to be looked at again, unfortunately. And we do have it electronically, but they did turn it off for a while because someone forgot to pay the bill. Okay, I've been drafting it at the last minute as well, so apologies that I'm not necessarily going to answer all the questions that I was asked to on COVID, but it's more about pointing out the disasters of our baseloads. But I couldn't not come and talk about baseload without talking about London Underground. So just to introduce the type of chart that I'm going to show through, I thought I'd put a year's worth of London Underground energy data on the chart. Can you see the mouse pointer moving?
Yes.
Brilliant. Okay, so here, and again, I'm colorblind, so it's not great, but I think that's red, that's blue, and that's black.
That's right.
Okay, so what this is chunked up a bunch of half-hourly data, and this is your average weekday with your morning peak and your afternoon rush hour that tails off, and an overnight baseload of around £5,000 an hour. Your red is your weekend, so no rush hours, but it lasts longer into the night because, of course, we've now got night tube, so a higher base load at night, and the black line is just a peak day to show you how varied it is from the maximum demand. Over COVID, oh, and obviously, sorry, I'm glad I put that there. It reminds me, this is kilowatt hour data. So that 20,000 kilowatt hours over a half-hour period equates to 40,000 kilowatts of demand. Base load, keeping all the trains warm no matter what time of year, just in case the heaters don't restart. Bear in mind our 150-year-old infrastructure. Over COVID, what we get is the solid lines. So we've had to keep running our service, despite the fact there's nobody on it for a fair chunk of time. And this is from a week in June, I think. Week 12 was around June time, and our weekend loads are lower. But our base load, interestingly, obviously has dropped to slightly less than that 5,000, and there is no night tube because no one can go out. The numbers over here are the equivalent annual cost, so £115 million a year in energy alone, let alone all the staff running the network for you people. Okay, so what I came to talk about was a tale of two empty-ish buildings, because the one thing that we have been able to learn from COVID, when 12th of March, pretty much the entirety of 15,000 people in TfL were told, go work from home, it's too risky. So we've got Endeavour Square, which is the building that is our newest building. It's our best building from an energy and deck perspective. It's a D77. That is the building that I met Roger on. And it's pretty good because it's connected to the Olympic Park district heating, and it's got passive chill beams. It still has this vertically fed ventilation, so every single floor is being fed by the same level of fan cool, same level of handling units. Some are in, and so we have these issues around the AHUs. And since the 12th of March, it's had a sum total of about 25 people in it. Pier Walk's our second newest building from 2009. Again, it's relatively a good performer for an air-conditioned, fully air-conditioned building at 112. But it's got traditional electric chillers on it, so and you'll see some of that in a second, and active chill beams. So we're pushing air to those beams rather than a displacement vent system. That's an even less occupants, 5 occupants since the 12th of March. That has literally been mothballed, for want of a better word. Just security and a few FM staff. So,
Quentin, just a quick question on that then. So just out of curiosity, do you have any sense of, so what was your kind of peak numbers in both buildings during normal operation?
About 2,000, yes, I should have mentioned that. They're both similar size, 10 stories on the Endeavour Square side, and 6 stories at Pier Walk, but it's a slightly fatter footprint. So yeah, they're very similar sized buildings.
So as a follow-up question to that, How many people do you think are going to be in it in 3 months' time and then 6 months' time?
Depends what someone asks us to do, whether we have to follow this, whether we have to be seen to be leading the light to bringing people back. It's, I would say, half at this state if we're going to keep social distancing going. So it's going to be an interesting time. I can't really confirm one way or the other. So from an energy perspective, so the similar sort of chart from a pre-COVID position. We've got the weekday the weekday average in blue and the baseload in red. I'm blending them into this, I think, orange color, just to say that's the average for the week, because otherwise the chart's going to get a bit busy. What you notice from Endeavour Square is that the peak doesn't rise much more than the average, whereas in 14 Pier Walk it's much higher, because on your summer day, 25th of July, all those electric chillers are kicking in at 200 kilowatts a time, and it really chops and changes everything. And we've got a bunch of pumps as well that have to run at night because we've got a serious water circulation problem. But overall, you know, the annual estimate was around 400,000 pounds worth of electricity at Endeavour Square and 460 at Pier Walk. So again, similar size. Pier Walk's slightly bigger. So what happened during COVID-19? Well, everyone got sent home, and then about a week later, us and our energy team went, all right, what can we turn off? Come on, these buildings are empty, or as near as damn it. Well, week one, we hadn't managed, you know, the people had effectively left, and the BMS was just kind of doing what it was doing before. By the time we got to week three, we'd actually done some changes. We'd managed to find the fans that were still running at their, you know, essentially the floor occupancies. These are all demand-driven buildings, so the floor occupancies were set at 8 to 6 still, as if everyone was there, but nobody was. So a lot of those loads were the air handling kicking in, which we managed to switch various things off. And over the course of time, we've ended up, again, by about mid-June, we're somewhere around that weekend average in both of them. In fact, at Pier Walk, we've dropped below. What we're seeing here, I think, is security walk-arounds still happening and bringing on lights. That's what those peaks are, because the lighting systems come on for 20 minutes and then drop away. But we're still sitting at around 260,000 pounds a year. So over £500,000 a year's worth of electricity for circa 30 people. So what I wanted to then delve into was what's in that baseload. Well, this is an old report that we developed that would take a year's worth of electricity half-hourly data and split it into the weekday on the left and the weekend on the right. The black line we know is our fiscal meter, that's what we're paying, and that's our weekday average and our weekend average. The blue lines are from sub-metering, from floor lighting and power and from comms rooms, and the red is a kind of a virtual meter. Well, we know we've used it up to the black line, so that must be everything else. It's a central plant, miscellaneous loads. The scary bits are annual out of hours. So our out of hours is essentially any time from this vertical line around 6 o'clock on a weekday through to about 7 o'clock in the morning, and all of the weekend, right? Okay, Pier Walk does have one floor that has a contact center in it, so there is an element of one quadrant on one floor that does run out of hours, but that's how we measure all of them. 200,000 pounds, 240,000 pounds a year here, and the scary numbers are the kilowatts, you know, of so that central plant, whatever it's doing, that whatever it's been commissioned to do, and the BMS is letting run, a minimum demand of 140 kilowatts, and the floor lighting and power, this blue stuff, 80 kilowatts. When we came to COVID, we thought we'd try and drill down and replicate this chart for this building. Unfortunately, the metering was dead. Half the load, it has a fabulous super logger in the loft, in the roof plant room, and they've been broken. And for the want of £2,000 last year, they didn't sign off on the expenditure. So all we can see from COVID is the total, that incoming fiscal supply. So the black dotted line is what it was just before lockdown, so around about the beginning of March. That's a sample week, and this is a sample week about 5 weeks in, so yeah, 11th of April, when we pretty much got it back down to that base load. We've got it a little bit below, in fact, if you looked at the weekend from March time. What I wanted to sort of highlight really is here, because we were doing some work with Letty around net zero. And at the moment, that greys and blues here, where we were in an empty building, just running at a run rate of about £280,000 a year, 95 kilowatt hours per metre squared, and the net zero target for 2050 is 55. So we're even at base load, we're 72% more than that target, and when we're back in that occupied, we're 61% higher than that base load. So I just wanted to remind people about net zero. You know, we're trying to build up on our renewables component, so as much as we can by 2050, and we're trying to drop down our demand. And so if our demand meets our renewable supply, then supposedly we're net zero if you don't count all the embodied carbon in all those renewables, and everything else going on from a new iPhone through to a new building. But there we go. And to get there, UKGBC has set out some whole building targets, and all our data is in GIA because we do DEX, so that's where that 55 comes from. So we were trying to get to 55 at a whole building level by 2050, and we were at 95, remember, on the base load, so that's not even meeting the 2030 target. Okay, so can newer metering work? Because, you know, Endeavour Square's 2017, surely it must be able to work. Unfortunately not at the time, because 3 years in, we still can't get the fiscal meter data out of the landlord's managing agent in later than 6 monthly chunks. However, fortunately, because Roger was involved in setting the billing strategy, we do have some landlord check meters, for want of a better word, that doesn't cover everything, but it covers enough. So this is some live data from the 16th of March through to the end of June. And what we get is, again, we've got that black line of the total consumption. Left-hand chart is weekday, right-hand chart is weekend. You've seen they're pretty much getting to the same point, but there is still some weekday running. This new blue line is because we've got 5 other tenants, so Brett and others were still leaving things running. So now out of hours is pretty much all the time, and that's where we get that 260-odd thousand pounds a year run rate on electricity, with pretty much 25 people there in the building. Again, the HVAC sitting at around 60 kilowatts and the small power at 76. So here we can actually drill down. So what I wanted to do was then drill down into our lighting and power, that blue one from the chart for this blue base load, yeah, because that's the on-floor stuff. We've got floor lighting separate, floor power circuit separate from ceiling power circuits. Now in this building we've got an LED lighting. So what we've got here is this is the weekday before COVID, and this is the weekday after COVID, or after lockdown started and everybody left. And the point being is, yes, we've not got that peak where no one's really coming into the building. We've only got these people on the first floor, but somehow amazingly, we're still spending 100 grand a year on the lighting and the power, and those LEDs aren't really turning rapidly overnight, even though there is literally like one security guard on it. Still pulling 35 kilowatts of lighting at all time, minimum. And the small power loads, yes, we've got some PCs that are there that have to be left on for people to remote into, so thick client PCs. Some of the people doing CAD work from home have had to have this special setup where their own PCs stay on, 40 kilowatts running at times. On the slides, okay. Pre-COVID and lockdown, we're having to run ventilation. We've tried some REHVA guidelines around running all the fans for an hour every day, even in the occupied spaces, and run for as much as possible. So that is the fresh air side rather than recirculation. Fortunately, this building is space where there isn't any significant research. In our buildings with fan core units, that's a significant challenge. And here again, we're spending 114,000 on these HVAC loads. We are still investing with our BMS provider. I had a call with them today, and quite literally they found some meeting room overrides that are kicking in and bringing on HVAC out of hours when they shouldn't be, because essentially it's not been commissioned because they haven't had this sort of opportunity of an empty building. And I think that's probably the biggest takeaway is when buildings get built, you really need that commissioning time so that you can prove that when no one's in the building, the minimum power consumption is happening, and you never get a chance to do that. So it's been a really unique opportunity to capture data. And my last slide is, even at 5 Endeavour Square, where it's our best building, that base load of 25 people in the building sitting at 60, oh, pardon me, there we go, 65. So even that base load of a brand new building is not Paris. That's me.
Quentin, that's really fascinating and rather disturbing, actually, isn't it? It's a real quick question because we are already running over time slightly. No, it's all right. So one of the things, it's a question that's come up in the Q&A, and I'd like to expand on it slightly. The question talks about whether the BMS is exposed to react to building occupancy, and I'm sort of wondering whether your thoughts on the idea that actually, although it does react to building occupancy to a certain extent, the building management system is really only controlling the environmental conditions. And actually, if it was able to control a bunch of other stuff, like, I don't know, turning the power off to your computers or turning power off to small power, whether that in its own right would have had a significant effect.
Yeah, it's an interesting one. I mean, a few years back during one of the CIBSE campaigns, we had a security guard who ran around switching power off. It was one of the Earth hours, so March. That's also at the end of our financial year, and he turned the PCs off a bunch of finance people who were running their end of year calcs and got into a heap load of trouble. So there is an element of, if you allow automatic shut off of stuff, that things will go wrong from that perspective. On the BMS side, it's interesting in that this building had it was due to be demand led from and be able to shut off those floors, but that was value engineered out. We have run a trial on 2 floors because what we found is actually all the kit was there, the dampers were there, the motor controls were there, but it just been never commissioned because of some value engineering decision. We are trialing 2 different systems, a Light-Fi system that is essentially measuring Wi-Fi devices, which has got us into a whole heap of trouble around privacy, because obviously that collects MAC addresses that are your personal private data, even though it doesn't use them other than to have a count of how many people are on the floor, or an estimate how many people are on the floor. And we've been comparing that to a BMS solution, a standard BMS solution of CO2, because part of the problem is that CO2 sensors lag, and you find that the ventilation doesn't come on when you actually want it. It comes on after everyone's left. So that was the idea of using Wi-Fi, because that's a much more instantaneous feedback. We would like to roll that out to the whole building, and in this COVID world, we might actually get to that sort of level, because privacy has been kind of thrown out the window, because now everyone's sharing their Bluetooth to, well, maybe they aren't, but the government would like us to share our privacy data to track and trace. So why can't we jump onto the back of that to actually control buildings in a bit of better way? So that's neat.
Interesting, really good. Thank you very much indeed.
Okay, pleasure.
So if you could just stop sharing your slides, I think that would also might
Hopefully
help.
That worked.
It did indeed. Thank you very much indeed. That was again really fascinating, and as I say, ever so slightly disturbing. If we can't get to the 55 kilowatt hours per square meter per year on an empty building, then are we doomed? I hope not. So our next speaker, and I apologize to everybody on the call, because I suspect that this event may last a little bit longer than the power hour that I was promising you, because we are running over somewhat. So our next speaker is Shrikant Sharma. Shrikant is the director and head of the analytics team at Pier Walk Engineering. He uses data to study people and analyze human behavior, which perhaps, does that put him into the category of Big Brother? I'm not quite sure. Anyway, he's going to talk to us about rethinking the working environment, about health and well-being. Shrikant, the floor is yours.
Thank you very much, Roger. I'm just conscious of time, so I'll get cracking without too much of introduction to the talk. It's really about thinking about people, and the question about, has energy taken a back seat? I would say yes, and I hope it has, because ultimately buildings are designed for people. We know how much impact the built environment has on all aspects of our lives, whether it's about health, well-being, productivity, carbon, safety, and really vibrancy of the places that we design and occupy. We do know the key challenge with the building industry in terms of efficiency and productivity. There's numerous reports that we know that compare the productivity in compared to a number of other industries where the level of productivity has remained more or less flat compared to several others. And whether it's wastage in terms of material, labor, energy, and I think for me, one of the key challenges is not just efficiency, but the lack of predictability. The buildings that we design and build can be too busy at times, too empty at times. It's really knowing what the usage of those is going to be and what it is, so that we can build that, use the data and evidence into the design. And it's really that lack of predictability and flexibility and resilience driven by not necessarily lack of data, but lack of good quality data and insights that will guide us into this. So fortunately, a lot of that is changing, and that's driven by just a huge number of sensors, IoT devices, and the ability to link those into whether it's space utilization or security, safety, surveillance, understanding really how buildings are used. There's tons of that data being generated. The question, of course, is how do you use that? How do you turn that into actionable insights? And here's an example of some of the work that we've been doing with our partners at Vodafone and GE, where turning number of data from sensors such as CO2, noise, temperature, the usual environmental sensors, but also with people occupancy sensors. So as Roger said, one of the areas of my interest is understanding human behavior. And if you could, without being too big brother about it, but really anonymized tracking of people in a hot desking environment, really look at how people use these spaces, desks, meeting rooms, informal meeting areas, entrances, etc. Start to really generate insights into how these spaces are being used. Then the outcomes that jump out of this very clearly is you can optimize the right amount of space, the right size of meeting rooms for people, and cut down, significantly improve utilization. There's also being able to understand the productive hours versus not, whether it's about CO2 levels maintained in different parts of the space or other environmental conditions. But I think one of the most significant ones that we've been looking at researching is about how people interact in workplaces and how you can use a lot of this data about what aspects of design and environmental conditions can drive better interaction. So we've been using a lot of that to refine the design and operations of these spaces. But of course, this is all pre-COVID world. In that world, you wanted to maximize the interactions to improve collaborations and productivity between people. But then, of course, we know what happened over the last matter of few months. We started generating these data sets, what you see on the screen just for Bureau Happold in the days leading up to the lockdown, and you can start to see as we normalize the initial few weeks of the duration of online meetings that were happening across our offices over the world. There was as the lockdown started to settle in, there was a 250% increase in those duration of meetings, 40% increase in the number of meetings, The average duration of the meetings also jumped up quite. So clearly more remote working, less face-to-face meetings and terms that's clearly had a significant impact, not just in workplace, but pretty much all aspects of our the spaces that we occupy. So what we did that the data analytics and the predictive modeling that we were doing with those data sets, we started to look at guidance into how you could use that information. So same floor plan you saw there, we were then looking at how resilient are our workplaces to maintaining social distancing and a 1 meter circle around people just to see how often that's violated, turns red every time people are too close to each other, which means that you couldn't just reopen the office at the same level as it was before, even if people wanted to get back, because you couldn't maintain social distancing. So we then looked at questions like, so what would it take? The answer tends to be somewhere between 20 to 40% if you didn't do anything in terms of changing the layout, etc. And then, of course, we've been partnering with a number of firms. This one, what you see here is work we're doing with a furniture manufacturer, HNI, where we're looking at taking the same space, seeing what happens if you reduce the occupancy level, and then said, actually, if you were to redesign the workplace, have a different space of the shape of the desk layouts, and then started to introduce even the approach, the in and out movement through that space, how you can really get back to normality with the same level of space. And then of course there's other angles like HVAC control, but really there's a whole combination of spatial and environmental and cultural signage, wayfinding interventions that you can put to make these spaces get back to normality. And it's not just the workplace, we are also looking at other environments like stadia and airports. What you see here is an example of theaters where we looked at if you had occupancy of groups of 2 or 3 or more, how many people could be occupying this space while maintaining social distancing, and obviously not just in their seats, but also as they walk to the bars and the toilets and the ingress and egress through that. Similarly, looking at classrooms, and we're working with a number of universities now to look at same models that were used in pre-COVID world to design for efficiency and better interaction, and is now looking at what measures can you put in to maximize that level of utilization, the capacity in a static sense, but also in dynamic sense. So really using data and analytics, not just at looking at the past, but also looking at the potential interventions. So what you see here is one of the several universities we are working with, where each building we calculated the capacity of the classrooms, seminar rooms, labs, etc., and using very simple interactive predictive modeling, looking at what capacity you have if you were to work with 2 meter or 1 meter social distancing, what extra capacity can you gain if you ran 2 hour versus 1 hour classes, what happens if you ran longer days or more number of days, and went all the way from spatial to temporal capacity, feeding into timetabling, then looking at how what the pinch points were both at campus level and at building level, and then going into environmental interventions, wayfinding, and ultimately building monitoring and control, because that's again another key factor into as we go into the future, into the new normal into the future. where these spaces are going to be occupied in a slightly different way. People will behave in a different way, and that's where there is a lot of uncertainty, right? That graph I showed you about the number and duration of people's interactions online versus face-to-face. What shape is this graph going to take? Is this where we're going to settle? Is this going to continue to increase actually in future as we get more used to this, or is it just going to get back to the normal as it was before? Obviously, nobody quite knows what that is, but the 2 points that I make here is, firstly, buildings are for people. The resilience and flexibility is fundamental to the success of how useful they are in the functions that they are designed for. And the other point is the predictability and certainty around the usage. Now, you can't really predict how that shape is going to pan out in future, but really using data, human behavior understanding and analysis and modeling, you can prepare a scenario plan much better for it. So that's where I would stop. Thank you.
Shrikant, that's really interesting. Thank you very much for that. Whilst we change over our slides, I would be interested to know. It strikes me that the Paris target of 55 kilowatt hours per square meter per year, which has been discussed a little earlier, do you think that's likely to, in a way, have to change? That actually maybe the metric we should be using is kilowatt hours per person in a building per year? Because actually, isn't that what it comes down to? Is the number of people you got in there? And based on what Quentin was showing us, that is a real big problem for us, because we are going to have fewer people in an office, and yet our base loads aren't really going to come down very far.
Yeah, and you know, the sort of the provocative answer to that question that rhetorically was put at the start, you know, has energy taken a backseat? Most definitely it has. I think COVID has simply accelerated the trend that was happening anyway. We should have never been using the per square meter or per cubic meter as the metric. It was always about people. It needs to be around people. I think a lot of organizations were already measuring performance, outputs, productivity, outcomes in terms of number of people, and I would say, as far as go as far as saying it should be about per activity, per interaction, because that's the key metric. And going forward, it's just going to be so much more important, and we know why. It's about flexibility, resilience, and ultimately about human productivity and well-being. So definitely, yeah.
Terrific. Shrikant, thank you very much indeed. That was a really good presentation. I'm aware that, again, we are somewhat running over time. I suspect we're going to be finishing maybe about 10 minutes late or so. So apologies for all of those attendees who have to leave at 7. So we're not going to make quite that. In fact, we already have missed that deadline. My next speaker is Phil Grunwald from Oxford University. He's a research fellow at the university, previously modelled energy storage for low carbon systems at Imperial College. And I suspect that Phil and Elon Musk probably get on extremely well, because Phil seems to spend most of his time trying to figure out how much of the millions of pounds in storage investment we can avoid, and therefore not have to buy batteries and the like. And he's done some fascinating research, which he will expand on now, about what we're doing with energy, particularly in COVID times. Phil, thank you.
Wow, thanks a lot, Roger. Yes, indeed. I mean, Elon Musk is sort of one of those big players who'd like to get his hands on. There's an estimate of about £40 billion worth of storage investment for the UK alone. But when we looked at that, we found that if we make small changes, for example, to our baseload, we can save a lot of that investment. So for that, Elon might not thank me all that much.
That might not be quite so easy.
Indeed. So yeah, as Roger said, I'm at the University of Oxford, and I've shown you a picture here of that wonderfully beautiful workplace where I wish I worked, but of course, in fact, I don't work there. where I really work is there. This is where I'm at the moment, in a corner in the attic of our house. And that's in fact what I want to talk about, the effect of this working from home and what that's done to our energy use. I should probably also stress that the University of Oxford is not only pretty and big in the news for creating COVID vaccines, we also have a substantial and really quite exciting energy research program at Oxford that covers the whole shooting match, really, from economics, policy, politics, various generation technologies. But what I want to talk about today is the demand and efficiency bit down here. But as you can see, the lines show you how all these things connect. So it's all one big system, really. But as we've already seen and heard, energy has suffered something of a, I like to call it almost a cardiac arrest. So this is the national grid electricity demand on the left of the line before the lockdown, and this is sort of the lockdown moment. And you can see how the gigawatts that used to cycle quite reliably in cycles on a weekly basis, that's completely been disrupted. I mean, the demand has gone down, but also the rhythm is completely gone. And rhythm is quite important for the system operators to sort of foresee. You can see here how the renewables vary. They have to account and cope with that. And while there's a very positive story that we've used a larger share of renewables than ever before, of course, it raises some questions of how we operate the system. A slightly different way to show this graph on a daily basis is on the next slide here. So here again, we've got the profile of a day. And again, days have quite common profiles of a ramp up in the morning, then a sort of plateau throughout the day and a peak in the evening. And this peak we're especially interested in because for a power grid, this is a problematic moment. But before we get onto that, spare a moment for what has happened from 2019. So this is the period just after lockdown. So from 23rd of March to the end of April. So the first experience of lockdown. If we compare the average days from 2019 with 2020, you can see a massive gap there. And we all recognize how significant the lockdown has been. But if for a moment we put that in historic context, it's one of those well-kept secrets that over the last 7 years, we've made phenomenal strides in demand reduction and efficiency. So you can see here the profile from 2013, 14, 15, it goes down every year. The only one where it hasn't quite gone down was 2018, but other than that, a very steady fall. And 2020, in a sense, what happened with the lockdown, we've almost wound forward into the future a little bit, and demand reduction clearly may continue. But what we're quite excited is to get this insight into when you change a system so dramatically, what actually happens there.
So Phil, just a quick question on that slide then. Does that suggest that the evening peak has fallen less?
Well, the evening peak is fascinating, especially because it's a sort of, this graph is a mishmash of the commercial sector and homes. And we've made great progress on peak, reducing it by having far more efficient lighting. So lighting was a big contributor to peak demand, but you can see it sort of starts to stand out a bit more, and that could be a problem. The more the peak stands out from the rest. Don't want to go into too much detail here, but what it means is a lot of what we used to call baseload plants get less work, and you rely more on what used to be called peaking plants that sit idle most of the time and then have to come on for these moments, which makes them more expensive to run. So it is really, both for a system security and for a cost perspective, a tricky moment. Now, the other thing we're looking at, so this is following on from Shrikant's spying on people. We do the same thing with a friendly cohort of friendly volunteers who record with our app what they do throughout the day. And here you can see the breakdown of a typical UK day from 7 in the morning. So you can see here, we just classified it very coarsely by leisure activities, food, caring, personal, travel activities, work and housework. And there's a first flurry of activities that we usually get in the morning. Then during work, people do work and don't report quite so much. And then this period here, since we're talking about the power hour, we really are in the power hour. It's the power hour in terms of demand. And it's when most households really have to cram in a vast number of activities. You come home, you have to prepare meals for the children, wash clothes, everything happens in this really compressed period here. And so it was fascinating for us to see, this is pre-lockdown, what happens when you put a society in lockdown. So we were able to ask people to continue to reporting throughout the lockdown. And what you see on the right here is the dramatic shift that we've seen. So the top line here, this is what the reporting pattern used to be with this, intensive hour in the evening here. And that has dramatically dropped. The evening has become less intensive. People seem to be getting up somewhat later. That seems fair enough. If you don't have to go into work, you might as well have a little bit of a lie-in. But there seems to be a real shifting of this activity block here into the daytime. So people suddenly have a bit more freedom to shift about when they go about their tasks. For those who are interested in more detail, here's a whole breakdown of which activities have been reported less often. Travel, obviously, standout candidate here, but socializing, work have also gone down. And then interesting also to see, what we've done with that time. So additional screen time, recreational activities, especially in the early days of the lockdown. Hot drinks keeps coming up. People cope with all sorts of things by having a hot drink. And then gardening, probably helped by the good weather that we've had in the early days of the lockdown, has seen a big up. Now, the really interesting thing is when we start to connect these data on activities with data on electricity use. And this is a graph that shows you, so each household that does these activity reportings also has high resolution electricity recorder on their mains meter, so we can see how and when they use electricity. And this is data, again, actually from before the lockdown, where we compared people working from home and not working from home. And the very pattern that we've just seen from the lockdown, this shift from this busy evening into the daytime, and also the shift towards a slightly later start, they're both here. So in terms of good news, although of course there's a higher demand overall, people working from home will have higher energy bills, and we should talk about that as a potential issue. The good news from a systems operator point of view is they do exactly what we'd like them to do, which is avoid that early evening peak period here. So that's being reduced by home working. So we suspect that what will happen as a result of lockdown and maybe continued working from home is that we increase home demand, but we may be able to reduce that problematic peak. And that's the whistle-stop tour of what we've been collecting data-wise. So we may be facing the end of the office, as we've just seen from Shrikant. It's really quite difficult to make offices socially distant. We may get a reduction in peak demand, but yeah, we also have improvements on travel demand. For me, the exciting thing that's happening here is the flexibility that we see. So what happened is people who are at home can now suddenly run the washing machine at any time in the day, and they do. So washing machines that used to be run in the evening, we now see very often being run in the morning. And as a sort of call to action, I suppose there's an even greater call now to increase and improve the government's commitment to refurbishment of homes, make them more efficient, install new heating systems that allow us to be more flexible in the timing of when they run. And to underpin all that, I suppose we do rely on better IoT systems, so that a lot of these building management systems that are common in commercial buildings can also hopefully help us in the residential sector. And that's me done. Thank you very much.
Phil, thank you very much. That's again absolutely fascinating. Some of the data there is well worth having a really good sort of look through on a closer perspective. I am quite interested in the idea that firstly that one of the things that your slide showed was that those people who work from home, their baseload. In other words, when they are working not from home, their baseload is still significantly higher than it is during the evening, which I found fascinating.
Yes, I think it's a real theme that runs through this whole event, is how high baseload is and how difficult it is to reduce it. And of course, since we focus on activities, baseload slightly eludes us. And most people, we send people their profiles after they've taken part, and they can sort of analyze their own patterns. And most people are aghast how high their baseload is and the nighttime consumption, and very few can explain it. And anyone who's tried with their own in-home display to get it down to zero, it is tough. Yeah. and it probably deserves a bit more attention, what actually goes on in the night.
It would also be very interesting to know, so given that so many people have been working from home during this period, if you were to add up all of the energy associated with building use for any particular organization. So sure, the energy use in the office has gone down, but the energy use in all of the homes that those same workers are now going into has gone up. So overall, from a global standpoint, if you were to look at an office, is the total amount of energy used by the people doing the work for that company gone up or gone down if you add in the additional energy used at home?
Yeah, I mean, it was fascinating to see how difficult it is for buildings, even if they're not occupied, to actually get the energy down. So that suggests that, you know, we might have had some net increases there, and a lot of the demand we see overall is actually, you know, some of that industrial activity that is reduced. I suspect that it slightly depends on how we organize ourselves. You know, if you have people working from home and there's still office space for them at the same time, then that might be a net increase in demand. But if we get that arrangement right, I'm sure there should be some benefits. But we've been lucky, you know, so far the lockdown has been in very pleasant weather, just sort of the end of the heating season. Fingers crossed we do not get a second wave in the winter when people would really have to heat their homes a lot more if they work from home.
Phil, that's really fascinating. Thank you very much indeed. Just as a reminder to all of the speakers, there are a series of really good questions coming up in the Q&A process. So please help yourself and answer them. I'm afraid I am going to move on and try and avoid those questions, if you will, because our next speaker and our last speaker is Andrew Toa. Andrew works for NLX, which is it's an organization doing energy. He's leads the customer insights division in Europe. He's got a background in building service engineers, so he knows kind of what we're talking about. But in recent years, he's moved into the energy industry, joined XLX in 2016, and he's been working, some of his work has included the largest single corporate renewable energy purchasing program. Who and what was that? Can you tell us, Andrew?
Hi there, yeah, thank you. Yeah, actually, I can tell you a little bit about it. It was back in 2019, and NLX were selected to help Google with a very large power purchase agreement program. We deployed our auction technology to solicit power purchase agreements in both the US and Europe for that customer. So yeah, exciting project to be a part of, and you know, certainly something I hope to be involved in a lot more with corporates. So maybe if I can, thank you for the intro there, Roger. I'll get this away. I'll try and be quick, being cognizant of the fact we've run over a little bit. Just a little bit about NLX. Sorry, I'm going to have to stop sharing and 1 second, sorry, having a technology issue. My slides don't seem to want to move. Here we go.
They do tend to have a bit of a lag.
Thank you, everybody. A little bit about NLX. So NLX is a solutions division of NL. The NL group, you know, if you may have heard of it, you may not. It's actually a very large multinational power company, present in over 30 countries worldwide, and the NLX division, I guess our goal is to be the preferred solutions partner for businesses around the globe, and we've amassed a number of energy solutions that we deploy for our customers, and my area of focus is helping businesses purchase energy and manage that commodity risk. And I was asked today to kind of talk a little bit about how COVID-19 has impacted energy purchasing, and I thought this was just an interesting place to start. And you know, I was very interested to hear, you know, Philip's analysis there in the presentation before. But we have seen a quite step change in energy consumption and a significant destruction of demand, certainly in the UK and globally. And what we've seen is how different sectors are affected in different ways. And I suppose in a way it's kind of as you'd expect, really. There's not anything that surprising about this graphic, but I just find it fascinating to see how whole industries, travel, recreation, media and entertainment have seen such a dramatic reduction in energy consumption aligned to their shutdowns, whereas we've seen other parts of the economy have to actually ramp up in response to the impact of COVID-19. And this reduction in demand, or this change in demand, I mean, clearly it affects you if you are in one of these industries, but it's actually had a very big impact on the energy market more generally, and that's created some quite real risks and opportunities around energy, around purchasing of energy. To understand this a bit more, I think it's important to come at this, in my opinion, through the lens of a utility bill. So if we look at a typical UK electricity bill for a commercial or industrial customer, it might look something like this, where less than half of the cost of the bill is actually related to the commodity, the supply of the electricity itself. And the rest of that, often over half of the bill relates to various network charges and levies. So network charges would be the parts of the bill that are paying for the distribution and transmission of electricity, and a myriad of levies, because we like to do things in a very complicated way in the UK, a myriad of levies that you see on the bill. If you're lucky enough to get that granularity of breakdown, you'll see various schemes that are designed to fund the deployment of renewables at the wholesale market level, or to fund things like feed-in tariffs. And the important point to understand is that the drivers for these costs is very different. Some of the costs are based on demand, some are based on consumption, some are based on capacity, time of use, and we really need to have that in mind as we think about the impact of COVID-19 on energy purchasing, and how we can mitigate some of the risks and realise some of the opportunities. So starting with commodity, just to focus on that initially, what I've got here is just some charts that looking at what is happening with gas pricing in the UK, in GB more appropriately. On the left-hand side here, this chart is showing the evolution of prices for the next 4 seasonal wholesale contracts. So what that means is, what does it cost in pence per therm to buy gas for this coming winter 20, summer 21, winter 21 through to summer 22? And we've really seen how that price has trended down. Now, in actual fact, we were already seeing a downward trend in this price before COVID-19. You can see even right back from the summer of 19, this has been trending down. It actually relates to, just at a macro level, there's an abundance of gas around. We had quite a nice mild winter last year. There were already concerns around the economic forecast, and on the right hand side, what I've got here is EU gas storage levels, so across the whole of Europe, how much gas is in storage for each of the last 6 years. So the yellow trend line would be gas storage and how it's evolved over the year since the start of the year in 2020. And you can see that we've got more gas in storage than we have in any of the last 5 years before that. This abundance of gas, coupled with reduced demand, was already putting pricing under pressure. And what we saw after COVID-19 was somewhat of a collapse in gas pricing. We've seen historically very, very low prices. It's been quite stable since the lockdown took hold, but some really good opportunities for customers who are able to purchase gas further out into the future. But of course, as we'll come on to talk about a little bit later in the presentation, just being aware, if you are in one of those industries that's maybe a little bit less confident around demand looking forwards, then you need to be very aware of things like volume tolerances that we're going to come on to talk about. But we you know, in summary, we're seeing you know, very low gas pricing, which impacted by COVID-19, but it was already a situation that gave rise to very low prices. But if we contrast that with electricity, we're actually seeing we're actually seeing a different situation here. So here we've got a similar chart. The GB baseload power prices for the next 4 seasons. This is in GBP, pounds per megawatt hour. And again, we were seeing the pricing come off coming into COVID-19 shutdowns. But when the lockdown happened, we saw a real collapse. And actually around April, we saw some of the lowest electricity pricing that we've seen for a number of years, actually. But this price has recovered. Actually, for most of these seasons, it's recovered to somewhere near pre-COVID prices. And this is largely driven by carbon pricing. So on the right-hand side of the slide here, we've got the trend line for EU ETS carbon prices. So this is the cost of buying an allowance for the carbon associated with electricity supply. We've already, without getting into too much detail, had a really interesting situation with carbon pricing across Europe, where for various reasons the number of allowances has been reduced to try and drive this cost up, to drive out the carbon intensive generation assets, the coal-fired power stations, etc., out of the grid, and really create a scenario where renewables make the most sense. There is a real school of thought that as we look at economic recovery, we need to find a way to tie this to sustainability and make sure that the economic recovery you know, takes those opportunities to really, you know, get to those targets that we talked about in the earlier presentations, to reduce demand, increase renewables, etc. The EU ETS carbon pricing, because it impacts the carbon intensive generation assets and, you know, helps reduce the relative cost of renewables. There's a real strong school of thought that this is quite an easy mechanism to use to do just that. And I think what we've seen in the last few months is quite a lot of speculative trading of this particular commodity, which has caused the electricity pricing to drive up. So we've really got a very volatile situation right now in electricity pricing, and in actual fact, it's becoming more complicated for people who are carrying out active risk management strategies to call this and to make decisions. I think if we saw a second wave coupled with the kind of economic news that would go with that, there's every chance we could see another collapse in carbon pricing. But then again, we could see some interaction with this market to drive this carbon price up to promote renewables. So really, the opportunity is to avoid these electricity costs and avoid this volatility and have that price security, to make some kind of structural changes to electricity, to look at things like on-site renewables, to look at things like market-based power purchase agreements. But I mentioned previously in the presentation that commodities less than half of the bill, and I appreciate there's a lot of words in this slide. It'll be available to the audience to take away, and I really just wanted to share this to kind of highlight some of the things that we're seeing on the non-commodity pass-through costs, so these distribution and transmission charges that we looked at, the various levies, etc. So the interesting thing is that because many of these schemes are recovered in the form of a kind of per kilowatt hour charge that you or your customers would be seeing on the bills, and there's a common theme where because demand has reduced overall, these very schemes are not recovering as much as they expected. And we actually have a very specific risk related to COVID-19 that in the back end of this year, going into next year, we're going to see these rates increase beyond any previous projection. So just by way of example, contracts for difference here, the second item on this table, that is a scheme designed to fund large-scale renewable deployment. It works in the basis of providing a kind of guaranteed strike price to renewable generators. Gives them, it gives those developers the confidence to invest in those schemes. What we've seen, because the market price dropped the way it did on the last chart, there was a lot more money paid out to these renewable schemes to maintain that strike price, and then that was kind of like a double whammy, because that was coupled with the fact that there was lower eligible national consumption. So overall, this scheme has a deficit, which will then be recovered later in the year, going into next year, with some higher levies on contracted difference, depending on the type of contract, electricity contract that you have. There's going to be some price risk here coming into the back end of the year and into next. I won't go through each of these in detail, I'm conscious of time, but I'm more than happy to follow up and answer any questions in the breakout room. But just to round this off, we've talked about commodity price risk. We've talked about what's happening in the non-commodity side of the equation. But COVID-19 is also introducing some really interesting dynamics, just generally around procurement. So what we're seeing in the market that people should be aware of is that there's a heightened counterparty risk. There is, to put it candidly, there is real risk of suppliers going out of business because of what's happened. So we would always advocate just to be a bit more aware of who you or your customers are getting into contract with, having that level of confidence in their robustness. Equally, suppliers are more aware of the heightened credit risk around end users, and we're seeing a step change in the level of credit risk requirements that suppliers are asking for. Things like additional security deposits or declining to make offers where in the past they've been very happy to. We've seen that transfer through to more onerous payment terms and clauses in contracts. Increasing volume, wherever we're seeing risk around reduced volume due to COVID-19, it's led to far more onerous clauses within retail contracts. I'll wrap that up there. Small point of power purchase agreements, very similar, potential for renewable scheme delays. But that, Roger, concludes the presentation from my point of view. Thank you.
Andrew, thank you very much for that. That's really interesting. It's always fascinating, I find, to see the way that particularly the electricity bills are broken down, and that actually, as you rightly pointed out, only 50% of it seems to be associated with the actual energy that you use, and the rest of it is all the other bits and pieces that go on top of that. And I do find it fascinating that that my understanding is that gas is not priced in the same way. Is that the case? Is it actually that most of the carbon tax goes on your electricity bill rather than your gas bill?
There are obviously various different schemes. For example, climate change levy would be a levy that's applied to gas. I call out the EU ETS in the context of the electricity pricing because it's just so strongly correlated, and we've got a hell of a lot of volatility right now in the carbon market. I mean, literally 8% moves in one day. And that we just see it straight away. We see electricity reacting. Gas is correlated, but to less of an extent.
Wonderful. Well, thank you very much for that. That's a really interesting presentation. I am aware that time has run on.